So now what is happening? There is also a possibility that whatever the results these large language models are generating, for example, this ChatGPT, the picture is available on screen also, the ChatGPT is generating some results. Now, if it totally dependent on the results of ChatGPT, for example, a person X went to hospital, let's take an example, a Medanta hospital, and the person X went for whole body checkup. The whole body checkup is there. In the whole body checkup, they have the X-ray, they have the ECG test, they have vitamins test, cholesterol test, blood sugar test, and all those tests. All those tests have been conducted, and the reports have been generated. Okay, reports have been generated, and through their mobile app, you receive their reports around 25 to 30 pages. The reports clearly mention your name XYZ, your weight, your height, your BMI index. Now, as a researcher or maybe a person who is using large language models, you have decided that you don't have the time to consult the doctor right now, and now you are going to upload your medical reports on the particular large language model. For example, you are using ChatGPT, and ChatGPT, you are going to upload it. You can upload your reports also. You can upload the images also. If you have not tried, then you can try it also. You can just upload it, and now you have written the prompt, because there is also requirement of prompt. It is another part of prompt engineering. You write the prompt that please help me to make understand these medical reports, and please also find out the key findings, that which are the parameters which need to be reworked, and which are the red zone or green zone and blue zone. Because you have seen in the medical reports there are color coding also, there are a range of values also, that this is safe, this is high risk, this is on the borderline. Now what has happened, Mr. GPT has given the results, and it shows that for example, a particular vitamin called vitamin D, it shows that it is having a deficiency inside your body. Now it says that you need to take vitamin D supplement, and it also suggests the vitamin D supplement also. So without wasting the time, because your total dependency now on that, which can absorb inside your body, and then they create a problem also. So now you are taking the supplement 1000 mg or whatever the requirements are there, and you start depending. After a certain period of time, you feel certain sickness or maybe another symptoms also, but you have thought that whatever the reports have been generated from ChatGPT, whatever their suggestion is there, it is all trustworthy, but it is not coming like that way. Because what has happened, certain vitamins like vitamin D, they have a different range of values for male and female. For requirement in winter, it is different vitamin D requirement. For summer, is different. But the ChatGPT is not being trained on these kind of reasoning capabilities of whole body checkup. So there comes the role of how can we have a total reliability on these large language model, how can be much trustworthy on these large language model, how they are authenticate enough these large language model also. So there are certain things, but this is also called as hallucination also. So there's one open research area for all of you to work on that. Maybe you can work after this class. Hallucination in large language model. So they create a picture and positional encodings. Okay, generation positional encoding. You can see here positional encoding is there. Multi-hit attention is there. Input embeddings is there. First of all, you have given input as a text. How's the weather outside? It generates the result. The weather is pleasant and the temperature is 35 degrees Celsius. So input is actually you are writing a text, and then you are generating the results. So there is input. Term is input embedding. Now what is input embedding? Coming back to the NLP part, because the machine need to understand your language. So understanding of the language is generally covered under the natural language processing uh, concept. So natural language processing is understanding the language and generation of language. So first you write the language as a prompt, computer understand the language, and then it generates the language. Okay, this is the functioning of NLP. Coming back, why NLP is required in the terms of large language model, in the terms of neural network, in the terms of understanding the language, because generally to interact Meta, Claude, Perplexity, we use our human language to have a conversation with them. And these conversation may be in the terms of voice control operation. You have a voice control operation also. You can build intelligent robots like autonomous vehicle, like internet knowledge stored in the human language that can be transferred to machine and machine to human. For example, there is a one ancient book you have found, and then you want to translate into the modern language, then you can use in the with the help of these neural network, with the help of these large language models, which are actually using NLP concept. ये NLP concept ही use कर रहे हैं large language models भी, neural network भी, कि कैसे किसी sentence को we can divide it into tokens. अब tokens, what are the tokens? We are coming back to that also. So coming back to the early days of NLP, we have certain, a space Odyssey program was there, which actually deals with, human evolution, artificial intelligence, possibility of extraterrestrial lives, and all those things. So machine can speak. They have written a book also on that part. Some movies are also there where machines are started speaking with the human, started making decision also. So these are some of the things mentioned in the slides. Machine can a test of Turing test also, that whether it is a machine or human. A judge was beside a door, and then a conversation has been done, so it has to be decided whether this answer is given by a machine or a human. So that is the Alan Turing test conducted back in the 1950s. So why actually it is all mentioned here, just to have a correlation with the historical data of AI and the NLP. Passing all these things, again coming back to the, like, you nowadays you have Alexa, Alexa to chat. So previously there was Eliza. In the back 1966, there was Eliza who was talking, with humans, and Eliza is actually talking in the terms of, if then else rules, some logic. It's not like that we are using, Siri or Alexa. They having, understanding and working on the concept of NLP and neural network. They were working on some logic, if then else rules, like, how do you do, please state your problem. Nowadays we all wear smartwatches. They can track our ECG, blood pressure, oxygen level, and all those things. And these devices are sending information from your device to the doctor and end users. And these devices are generating a lots amount of data, and that data is in the form of a, let me show you one more thing, the particular, this one. So maybe around 5 pages of medical record is generated for a particular test for one patient. Even once you visit, you're using a booking.com app, and then you're going to book a one stay hotel for your family. Then what you have seen, that you go for the reviews and ratings, that is 7 star, that is 8 star, people have given, or 4 star people have given, and then you book on that. That is the part of sentiment analysis. That is also a part of NLP, natural language processing also. Then there is also having a conversation with the agents, like you can ask Siri on your mobile to change the music library on your Spotify, to recommend movies or the series for whatever the platform you are using it. So, or these are all the part of conversation agents. Cortana is there, Google Assistant is there, Amazon Alexa is there. Maybe you all are using as if right now also. Then there are chatbots also. For example, you have, you have ordered a product on Amazon, or maybe Flipkart, or maybe any other, or maybe Blinkit or Zomato, Swiggy, whatever you are using right now, and the product is having a malfunctioning, or maybe it is deteriorated. Now you want to started chat with their platform, that on the Amazon, the product is not well, it is being, uh, tear up, or is malfunctioning, and that chatbot is having a conversation with you. And that chatbot has, based on some decision making, some logic conversation is going on. But sometimes these chatbots have a limited capability also. If the information or the data is out of their box, then they suggest to have a live confrontations with, the customers are there, or maybe users, or maybe their team is there to help you. So these are the some of the things that NLP applications that you are using right now in a day-to-day life also. So now the data is also being classified, structured data, as if all you know, that they have the particular rows and columns, attributes, they have the numbers, they have, They have the pictorial representation, the graph representation. For example, if I show you one picture is there, like this one. So it is kind of a structured data which is visible on a screen. Just a random picture, I've opened it here, and this everything is very clear that there is a delay in milliseconds, this physical topology configuration. This is structured data. But what has happened about the data which is related to unstructured data, like image of a person without the without any caption, unable to identify who this person is, an audio clip, you're unable to identify whose voice is this, a sudden video frame is there, that is unstructured, a word processing file, email without having any sender details, spreadsheets, paper columns, magazines. You just cut a paper, it is unable to identify that this paper belongs to which date and which day. So these are the now, as a human, this is a problem for humans also to understand this unstructured data. And we want the machines to have the replication of human intelligence in machine also, so that machine can understand this unstructured data. There comes the role of natural language processing to understand, to work on the unstructured data. Because why I'm telling you, you have a book on Spanish language and you want to change it into French language. There comes the role of natural language processing. There comes the role of large language models who are working on transformers. Actually, the main, the main, if you can see the transformer picture is there. There is feed forward, there is softmax is there. It is a part of a neural network also. So they are using neural network also. Embeddings and positional encodings, all are these parts of the NLP also. So basically transformer, which is the backbone of large language model, they are actually using NLP and neural network approach also. Let me come in again. This picture I have opened. Yeah, this one. Just give me a minute. This one. Hello. Now, coming back to the NLP analysis, this kind of finding a relationship between different sentences and words is actually a part of NLP, because you are writing something on that to large language model, that how is the weather outside, and then they are generating the results that since it is raining from the morning, since morning, so the weather is a little bit humid, but it is cloudy. So they having a relationship, a contextual information is generated from the previous sentence, whatever you have written it. Now another thing is that there are certain demos also available in these slides. Maybe afterwards I can share these slides with you, and you can use these demo and you can see these tools, how they are working, and how they are using the concept of NLP also. Okay, one thing more, I think we have discussed these conversation agents like Google Siri, and I'm skipping the slide. They have given the example of Amazon Alexa and all those things. There's a YouTube video link also, you can have a link. This is maybe you have used Google also. For example, you are going for higher studies to France, and in the France you are seeing everywhere the language is different, the notifications are different, the language is written in a French language. Now you want to talk to a cab driver also. The cab driver is maybe not speaking in English, and for example you are traveling from India, then you are finding a difficulty, then you can use Google Translator also. There are many other apps, and now there are many tools are also there, but previously we are using Google Translator also to type I need to reach to particular airport, and then you need to type and translate into French language. So like this on question and answering is there. Then there are certain link of a particular product and different requirements of IBM Watson is there, or maybe how they are using NLP concepts in their own technologies also. So you can have a click on these links. I'm not going to open these YouTube video links right now. Machine translation is there, what just now what I have mentioned about Google translation. Then you have this one is okay, just now I just discussed with you. And then I'm come sentiment analysis. I just talk you about, there are some negative tweets, there are some hate speeches. How to find that this is a negative review? For example, I say that last night I watched a movie, and for example, and the movie was okay. Now okay means what? Is it a negative review? Is it a positive review? So what I'm going to do, ratings, they're talking that it is hit up very fast and slow, and what are things are there, is their GPU is not good or whatever the things. Then based on that analysis, that is sentiment analysis, you come to the point that some words are repeating again and again in many of the feedbacks of the end users. So it becomes that it is a average review of these particular product also. This is also part of, you can do color coding also for that one, red, green, yellow, all those things. Structured data and unstructured data. Then NLP tasks. Now NLP के task भी, there are different tasks also of NLP. First task is tokenization. Why I'm talking about tokenization? If you can see, the figure is input sentence, how is the weather outside, and this input is become input embeddings and then positional encodings. Coming back to this part, if you see the components of LLM also, these are the NLP tasks. If you see the components of NLM also, you write one sentence, how's the weather outside? The sentence, now see, this is a machine. Machine does not understand your language. It needs to be understood through numbers. And that number is actually done, that's, vectorization of this sentence is actually done with the help of a concept called tokenization. It means you are changing a particular sentence or breaking into number of individual words. The lit pent is unsafe. This is our input, and the part of speech tagging is actually telling you about which is determinant, which is noun, which is adjective. So basically you are targeting the grammar or syntax, or maybe coming up with the semantic structure also. You need to focus on the grammar of also particular language, and every language has its own grammar. So basically you are assigning or tagging the a particular sentence which is broken down into individual words. You can see the lead pant is unsafe, the is separate, lead is separate, paint is separate, is unsafe is separate. And then you are defining which word is determinant, which word is noun, which word is pronoun, which one is adjective. This is done with the help of US tagging. And this separation of words from a sentence is called tokenization. There's an online demo also of this one. You can have and check on your own once the lecture is completed. After that, there is a name entity recognition. What is a name entity recognition means? Name entity recognition means that you are assigning names of a person, location, organization, domain, and all those things. So the sentence is that Bill Gates is the founder of Microsoft. Now you are assigning that Microsoft, the origin of the company is in which country. Maybe you can write US. Bill Gates belongs to which country? What is the relation between Bill Gates and Microsoft? All these kind of a things comes under the name entity recognition. आप कैसे recognize करेंगे कि ये इस person का name किस entity का है, ये किस place का है, कौन से time span क्या है, all these things. Then there comes the role of parsing, means sentence structure, like this one. Let's give you one example also. He saw the big dog. Then what is the noun phrase? Shallow parsing is there. T structure is there. Subject क्या है? He saw the big dog. Noun phrase. Verb. Noun phrase. Now, with all these parsing, dependency parsing, there is also a dependency parsing. Like the example is there. Bill Gates founded Microsoft. Now Bill Gates is separate, founded separate, Microsoft separate with the help of tokenization. And now Bill Gates is a person, founded organization Microsoft. तो यहाँ पे क्या हो जाएगा, एक सब्जेक्ट होगा और एक डिपेंडेंसी ऑब्जेक्ट होगा. So Microsoft is actually dependent on Bill Gates because Bill Gates founded the Microsoft, and then a tree parsing structure is created. Bill Gates found Microsoft. So tree structure has been created. With the term of a tree, if you can relate with some of the searching algorithms also of artificial intelligence, like if you're booking a cab or maybe finding a particular restaurant on Zomato, or maybe or food ordering or something. So you can search for the, shortest path, shortest route with this number of searching algorithms. And those searching algorithms, searching problems can be designed in the form of tree structure also. So that is separate case. But here is actually they are telling you about the noun phrase, verb phrase, that is the structuring of a particular sentence in the terms of a grammar, in the terms of a dependency, that is the parsing. Then there is this one I just mentioned, name entity recognition. UN official EQS head for Baghdad. Organization is United Nations. Official person is EQS. Head for location Baghdad. So your organization, entity, and all these things are. You can always also see the demo for these NLP concepts. Now, sometimes you have seen that you don't have a time to read the whole newspaper and you are rushing for your college or university or for your office, and you just read the keywords. You extract, your brain extract the keywords, headings, and just read it, the newspaper articles. You extract some information and you just go for the your work. So that is actually the transformation of unstructured information into the number of templates, word one, word two, template one, template two, template three, and they are being storing in your mind. Okay, so just information on information extraction in NLP. Then we just discussed the NLP task. Okay. Then there's also one example of uh, uh, relationship between a particular paragraph is there, starting with Bridgestone, ending with Metal Boot Club some month. So in this paragraph, how you are going to translate this English paragraph, for example, into a maybe in Hindi language. So what you're going to do is going to break this whole paragraph into number of sentences. For example, if I count the number of sentences, there are six sentences there, almost 5 to 6 sentences are there. Sentence one, sentence two, sentence three, four, five, six. Paragraph is broken down into six sentences. Again, the sentences is broken down into individual words. Word one, word two, word two, word three. It is tokenization. Then you are going to work on the sentence boundary detection, full stop, double colon, identify. Then you are going to find the tagging, that this is a noun phrase, verb phrase. Then you are going to identify this is a person name, this is a location phrase. Then you are going to find the structuring and dependencies of the words and the meaning of these sentences, that is semantic analysis. Semantic structure bhi hota hai. What is the meaning of particular words? For example, I say that there is a loan mela, LON, loan mela at the bank of the river. There is a loan mela at the bank of the river. अब इसके दो मीनिंग निकल के आ रहे हैं. बैंक ऑफ द रिवर मींस जो रिवर का बैंक साइड है. एक हो गया फाइनेंशियल इंस्टीट्यूट बैंक, लाइक any body like SBI or Canara, whatever the banks are there. So how our mind is going to identify these things? This is the part comes under the sentimental analysis also, because it is challenging for human also. I saw a boy with a telescope. Now the boy is carrying a telescope, a boy is using a telescope. The sentence is very difficult to analyze. So how a machine will analyze, this is also done with the help of sentimental analysis of those words. This is challenging for machine also. Now coming back to the same kind of ambiguity which I'm telling you just now. So NLP is hard also because they have the ambiguity. Ambiguity is like ambiguity is like mm, I saw the boy with a telescope. The bank organized a loan mela on the bank of the river. Okay, multiple meaning of words. How can you differentiate? And then you have this one. Uh, then there are some. Now they are coming back to the root word that this is good, this is best, this is excellent. Okay. Then there are one more thing. We have this one is with text. Then there is one more thing which is called as text vectorization. You have seen there's one one heading is there, text vectorization, and they are using NLP tool or NLP library for the programming to use this text vectorization technique. And NLP is natural language processing. What is now text vectorization? Why I'm talking about text vectorization? Because if you see the functioning of a large language model, which is actually dependent upon these transformer, they have some input. Just now we have seen the input, how's the weather outside. Then before input embeddings, it is changed into tokenization. What tokenization? Just now we have discussed. Now once the tokenization is done, you go for input embeddings. Input embeddings means, let's come up for that text vectorization. Embeddings being explained with the help of text vectorization. Till now, you have learned that AI agents or computers cannot understand the words. They cannot understand the human language words. They understand the numbers. You need to understand 0 and 1. Now, with the help of tokenization, you have convert a sentence like large language model is amazing, or you have written a word sentence like artificial intelligence is amazing. Now you're going to convert into number like 1012 comma 294 comma 90886721. So these numbers are actually generated by dividing the particular sentence into words and words into numbers that are called as tokens. And there are multiple tokenizers. Word tokens are there, character tokenizer is there, sentence species are there, subword tokenizer is there. For example, there's a word called unbelievable. Unbelievable means unbelievable. Un word one, believe word two, able believe three. So you divided the unbelievable word into three different words. So why I'm doing this? Why the system is doing this word? Because they can be manageable. Now, how the computer understand these tokens? For example, the word dog is there. How it understand that this is a particular pet dog or it is a wild animal? It is done with the help of vectorization. That is the topic here, text vectorization, which is part of NLP. It is again a part of large language model transformer. If you can see the machine learning pipeline, we have some training data is there, we have some feature vector is there, machine learning algorithm which is predicting the results. Sometimes there are difference in the actual and predicted results. We need to reduce that error. Maybe for neural network we can go back propagation, adjusting the weight and all those things. So this is general structure of a machine learning pipeline. And data can be structured and unstructured. Data can be numerical, can be categorical, and can be textual. Similarly, you are going to encode it. You are going to transform into numbers. Tokenization, words form is there, encoding is there. For example, you click a picture is there. If you click a picture, it can be transformed. It is actually made up of pixels, and to you do the normalization just to convert into 0 and 1 the particular pixel, because machine again understand the language of machine does not understand the picture, it understand the numbers actually. Same with the sentences also, it understand the numbers only. So machine learning with the help of, you can see NLP components, tokenization, part of speech, parsing, all those things that we just now discussed. And then there is a vectorization, which is we are just discussing now. And then machine learning model predicts the next word. And this machine learning model can be any large language model. For example, ChatGPT, as if now. Vectorization, machine learning model, and then prediction. But then how this machine learning model is there? So you have some data, which is can be in the templates, which we can be in the unstructured. You remove the noise, there's a normalization is there, just change it into, removes all those noise, just do the normalization, and you change it into some, for example, if a picture is there, you just normalize into 0 and 1. And tokenization, your sentence there, you go for the tokenization, you break the sentence into individual words. You need to find the unique words. For example, if a sentence is that i am I'm having an umbrella, and my umbrella is blue in color. Today is raining, so I'm using my blue color umbrella. I'm having an umbrella and my umbrella is blue in color. Today is raining, so I am using my blue color umbrella. Now, if you see this sentence is many repeated words which are of no use. There are certain words like is, my, they're also of no use. I want to remove those words and create a dictionary of a unique words. That is called as vocabulary. It means I'm creating a dictionary of unique words, removing the repeated words, removing the words which have no weightage, is, the, are, and a dictionary also. Dictionary means unique words. So there is a text is there, then vectorization is there, changing number form. Number form is there, then you create the dictionary vocabulary, and then machine learning model is there to predict the next word. This is steps involved in processing a particular text. Now, in the text hierarchy also, you have some corpora and corpus. जो भी डेटा का कॉर्पस होगा, बहुत सारे डॉक्यूमेंट्स होंगे, फाइल्स होंगी. And if you talk about large language models, जैसे आप you ask that which is the best number, for example, and one student says 42, another student says 42 because it is the highest number in the class. So which one is correct? Both says 42, but one says with explanation, another says without explanation. The one which says with explanation that 42 is the good number because it is the highest number in the class, that is the correct answer. And that is the same kind of explanation we want from large language model. This is part of explainable AI also. That what is the explanation of generating these medical records, how they can be authenticated, and this is done with the help of reinforcement learning. This is done with the help of deep reinforcement learning, neural network linked with reinforcement learning, and optimization of these machine learning models also. Now, you can see the corpora, corpus, document, tokenization, doing for translation of one language into another language with the help of large language model, which is actually using transformer. Again, coming back, transformer, this picture. Transformer has some input embeddings. Input is in the form of a sentence. How's the weather outside? And weather outside is changed into tokenization, number of words. Words have some numbers. That's transforming numbers. It becomes the input embeddings, vectorization. How this vectorization is done is actually all the part of NLP. So this is the pipeline. Raw text, tokenization, dividing the number of words, text cleaning, part of speech tagging, like this is verb, this is noun. Stop words. Stop word. What are the stop words? How is the weather outside? Is and the are the stop words. We don't want them. Lemmatization means uh, running, runs, run, flying, fly. You remove the ing and runs. Just only make the base word run. Fast, faster, fastest. Remove all those words. Come up to the root word fast. This is lemmatization. When you have clean text, machine learning model, maybe AI agent is there, and generating the next sentence. This is general structure of the NLP pipeline. Now, again, coming back to the text factorization, excellent movie. This AI agent or computer does not understand these languages, excellent movie and all those. It is a human language. Even someone who's working in a France does not understand this language also, because this is a particular country language, or maybe a general language used in different countries. For example, if you are living, if you are a Hindi speaking person, maybe you are not aware of speaking in Sanskrit, or maybe in Marathi, maybe in Gujarati. We need to learn those languages. Same thing with these machine learning model also. They don't understand it. To make them understand it, you use the concept of text factorization. So it refers the feature of technique used in natural language processing, transforming words into numbers, and documents into vector space model. So it is convert. What is text factorization? Is actually the process of converting a particular text written in a particular language or data into a numerical format, so that machine can be used for understanding. Machine can understand it with the help of algorithms and generate the next contextual information. Okay. Then now you can see the heading, text factorization and word embeddings. This embedding word, can you see here also? Now you can see the relation between large language model, which is working on transformer, and the relation between NLP. You need to have a relation with them. Everything is connected in the terms of artificial intelligence. I want to connect neural network also. Can you see feed forward, linear, softmax? This is a neural network property or neural network concepts. So you need to understand the neural network. It is not like that you just directly coming to the large language model. You have a clear understanding of neural network, that is convolutional neural network for images, recurrent neural network for translation, LSTM for maybe memory in, memory out. Then there comes the role of transformer. Why transformer? Because it is multi-head attention. It can give attention parallelly to different words, 1, 2, 3, 4, parallelly, vertically. It becomes a very fast process, very fast in generating the language, where other neural network are a bit slow. But that's why nowadays you can see different versions of large language models, or maybe we have this is perplexity, and this is codex for for designing a particular code and project. And then there are other cloud and other things also. But before that, you need to also understand the functioning of these different. Every large language model is different. If you're using perplexity, so perplexity is more to first. For example, if I'm going to use perplexity here, um, need to understand fog computing. I'm learning about fog computing, and I'm just unaware about fog computing, for example, and I just said that, tell me something about fog computing. Okay. Can you do deep research analysis on the uses of fog computing and show me some research papers also? with source. Let's see what is happening right now. Now, what is happening while using this perplexity? I am having the different sources, a detailed comparison, a particular deep research on the fog computing, rather than having a general uh, general description of fog computing, what we generally have in the terms of ChatGPT. So what does it means that, and they work on the part of NLP. NLP, again, there are many components. One part is these models cannot understand language, so they need to be transformed into numbers. This is done with the help of text vectorization. So then there comes the role of raw documents, airline tweets, do the tokenization, remove the stop words, is, the, are, you. These are the stop words. Stemming, what are the repeated words, whatever the run, running, walk, walking, all those ing, remove, just come up to the root word walk. Process them, extract the frequency. See this term, this TF is term frequency. I have given you an example that particular word is repeating in a particular paragraph and sentence. So if the best word, BEST, best word is repeating in number of many paragraphs, so it means a sentiment analysis is done, that this is a good product, this is a good movie, this is a good book, like this way. Then here they are using decision tree classifier as a machine learning model. You can use any other machine learning model for classification. You can, maybe you are using a transformer to predict the next consecutive words. But this is one example they have given. Bag of words. What is the bag of words concept in NLP? So it means, again, you have a clean text, you break the sentences into individual words, tokenization. You build vocabulary means unique words. I am using umbrella. The color of my umbrella is blue. Today is raining, so I am using my blue color umbrella. So these are many repeated words are there. Blue, umbrella is repeating again and again. Why don't we have remove these repeated words and create the uh, a dictionary of unique words that can be called as a vocabulary set, that it is part of vocabulary set, and then generate the vectors into numbers form, so that the transformation generation of a sentence can become easier. Like this one. Suppose we have following three sentences. The sky is blue, the sun is bright, the sky is bright and blue. Now you can see there are many repeated words. Sentence 1, the sky is blue. Sentence 2, the sky is bright. Sentence 3, the sky is bright and blue. Like this one. Tokenization means you are breaking sentence 1 into individual words. You can see that we are in the separate, sky is separate, is separate, blue is separate, sun is bright, and all those things. Now there are certain stop words also, is, and you can remove these words also. But for vocabulary building, you need to keep the unique words. अब unique words कौन कौन से हो गए यहाँ पे जो एक ही बार आने हैं, repeat हो रहे हैं, तो उसको one time you have to write. The sky is blue. We don't have to write blue many times. Okay, all the blue is repeating. Sun brightened, and now we are converting into numbers based on their frequency, based on the number of times they are appearing. Although number here written is random, just for an example, don't go for their count. But this is the process of transforming word into next word. जिसका जितना वेटेज होगा उसको उतनी इंपॉर्टेंस मिलेगी नेक्स्ट कंसेक्यूटिव वर्ड जनरेशन में. जनरल पर्सपेक्टिव में मशीन इसी तरीके से आपकी लैंग्वेज को अंडरस्टैंड करता है, एनएलपी के कॉन्सेप्ट को, एंड जनरेट करता है. चाहे वो कोई एजेंट क्यों ना हो, लार्ज लैंग्वेज मॉडल जैसा, क्योंकि वर्क कर रहा है ट्रांसफॉर्मर में. अगेन ट्रांसफॉर्मर इज यूजिंग द कॉन्सेप्ट ऑफ एनएलपी एंड न्यूरल नेटवर्क. न्यूरल नेटवर्क क्यों यूज कर रहा है वो? क्योंकि डेटा सेट बहुत बड़ा है उसका. ठीक है, And neural network is generally used for large data sets like images, for speech, for any book translation, all those things, because they have the concept of memory also, and they use basically GPUs. Even most of the gaming words, they also used multi-agent systems like PlayStation games and window-based games, and they also use reinforcement learning. Even they also use reinforcement learning large language models. It is kitty and it is very cute. So now it is coming 2 times, kitty is 1, and then now you're recording the frequency of the words also. This is one example. The drawbacks I'm not discussing, there are just a theoretical question. Term frequency and inverse document frequency. Term frequency means how many times the particular word is coming in a particular paragraph, so that you can count the sentiment analysis also. Frequency of a term across multiple documents. फ्रिक्वेंसी ऑफ अ टर्म अक्रॉस सिंगल डॉक्यूमेंट्स, ऐसा भी हो सकता है एक टर्म बार बार रिपीट हो रहा हो, अभी हमने कुछ रिपीटेशन वर्ड्स भी देखे. टर्म फ्रीक्वेंसी, हाउ ऑफन द वर्ड अपीयर्स इन द डॉक्यूमेंट. इनवर्स, हाउ इंपॉर्टेंट द टर्म इज इन द होल कॉर्पस. कॉर्पस की बात हमने अभी करी थी आपसे, आई डोंट नो मे बी हियर, यहाँ दिस वन. मल्टीपल टेम्पलेट्स आते हैं, कुछ वर्ड्स मल्टीपल टेम्पलेट्स में आ रहे हैं. आई नीड टू एनालाइज ऑल दोस वर्ड्स. Frequency of a word within the document is called term frequency. Frequency of words across multi documents, it is called inverse document frequency. So there are the formulas for calculation of these term frequency. Frequency of word in a document divided by total number of words in the document. Then T is the number of times appear, D is the number of words in the document. Similarly, you have inverse document, you take the log of that particular total number of documents divided the contained total number of words in a particular different documents. Okay. Then the car is blue, the truck is blue, the car is red. You have 3 documents. You calculate the term frequency, you calculate the inverse document frequency, and then you can find the importance of these words which are changed into like this way. Tokenize, vocabulary building, and then vectorization. ये sequence आपको follow up करना है. Tokenization, although इससे पहले आप sentence analysis, part of speech tagging, ये सारी चीजें आप कर रहे हैं इससे पहले. You are doing all those things before that. This one. Word tokenization, sentence body traction, part of speech, name entity recognition, shallow part. तो information गलत हो सकती है. Movie was bad, but the reviews are good. ऐसा नहीं होगा. The milk is bad, the might taste great. I took my money to the bank. Which bank? River bank or financial bank? The teacher taught the student with the book. Student books or teacher's book? एक पेपर है, आप लोग इसको रीड कर लीजिएगा, अंडरस्टैंडिंग द लार्ज लैंग्वेज मॉडल. पेपर टाइटल इज अटेंशन इज ऑल यू नीड. Just go through this paper. You can understand the concept of LLM working and functioning with the help of transformer, which is visible on the screen, and how they are responsible in generating the results. Just now we have discussed one of the, results can be in the hallucination form. Just go through the terms like hallucination in our large language model. एक paper large language model hallucination भी है, which is basically related to authenticity and reliability of large language models. So go through that also. One is transformer attention also required, and one is hallucination in large language models. एक Apple जो company है उनका एक paper है, I think उन्हीं का है paper, एक hallucination in large language models. They have findings that all these large language models are actually not doing any reasoning. They are trained on a very large data set. Once they given the close boundary of puzzle solving, their results have been different. They stuck in those results. So Apple का वो paper भी read कर लीजिएगा. Hallucination, I think hallucination in large language model, and another is attention all you need to understand the functioning of transformer with the large language model. But to understand the transformer, again I'm telling you, you need to understand the concept of NLP, which we discussed today, and understand the concept of neural network also, because it is also used. I hope maybe some lectures they must be completed on neural network, or maybe they're going to complete. So you need to connect neural network, NLP, with the transformer and with the large language models. So with this, I have another session from 11:30. I'm going to end the session for today's class. In case you have any query or any question, you can email me